So no questions over the homework assignments. What we are starting today, and we will finish up probably on Monday, is exploring the focus and directrix. So we previously learned that a graph of a quadratic function is a parabola that opens up or down. A parabola can be defined as the set of all points x, y in a plane that are equal distance from a fixed point called the focus, and a fixed line called the directrix. And there's an equation in ways that we could actually go about finding this, dealing with these here. Now, I've decided to change up a little bit the notes, so we'll need to fill these in. So y is equal to 1 over 4p, parentheses, x minus h squared plus k. For the focus is our h comma k plus p. And our directrix is y equals k minus p. And our axis of symmetry is x is equal to h. And our other equation is x is equal to 1 over 4p parentheses y minus k squared plus h, with the focus as h plus p comma k. Our directrix is our x is equal to h minus p, and our axis of symmetry is y is equal to k. And our vertex is going to be the point h comma k. Now we're not going to focus too much on the graphing, actually being able to graph it, but we're going to focus on the equations themselves. Now part of the reason I did change the notes is because I'm trying this out for the first time. Because normally in years past we've started out with the equations that they gave you, and then eventually moved on to these here later on. But I want to see if using these here is actually going to make it easier to work with. So let's go on and look at some examples using this here. Now, most of the examples we'll work with here today and Monday, the vertex is going to be 0, 0. It's going to be 0, 0. Now, one of the ways that I would know that if I wasn't just directly telling you the vertex is 0, 0, is when I look at this equation here. We have an x variable, yes? We have a y squared. Do we have any other variables? Well, no. In any of these equations, even with the x minus, so don't be writing this next part down. So like y minus 1 squared, if this was a part of it, and we were trying to get there, really what it would show up is actually distributing this out, which would be our y squared minus 2y plus 1. If the vertex was not at 0, 0, I would have this here, a 2y, because it's the y squared. If it was x squared, we would have an x to the first power. And we would also have a constant term, a number without a variable. So if the parabola, or this focus on a parabola that we're looking at, so negative 4x equals y squared, if the vertex was not going to be at 0, 0, I would actually expect to see a constant term, a number without a variable. Or since y is squared, I would also expect to see a y term. So I'd expect to see y squared y and a constant, or at least two of those, y squared and constant, or y squared and a y term. If it was x squared, the x was actually squared, we would expect to see x squared, x, and a constant term, at least two of those. Here we don't have it, so it's really telling us that the vertex is going to be at 0, 0. So our vertex is at 0, 0, which is really telling me that h is equal to 0, and k is equal to 0. H and k are both going to be 0. Okay. Now let's look at the formulas that we have. So one of them, we have y is equal to 1 over 4p parentheses x minus h squared plus k. And the other one is x is equal to 1 over 4p parentheses y minus k squared plus h. In both of those equations, one of them, y is by itself and doesn't have any exponents, yes? And the other one, x is by itself, it doesn't have any exponents. So even with the parentheses, so I'll just go on and write them out here. With these parentheses in both of these places, the y and x both are going to be applied to that square, that exponent, yes? Because if I have something in parentheses, everything inside of it will be squared in some way, shape, or form, yes? Even if we use distributive property. So I have the equation negative 4x equals y squared, yes? Which one is dealing with squaring y? This one here, yes? So this is the general equation for it. So we're looking at these equations, we're trying to see which one is squaring. What is our squared term? And a lot of what we'll be doing with this here in 2.3 is really matching these back up. What is it compared to? What does it match up to? What is its general equation? So here we have the x is equal to 1 over 4p times y minus k squared plus h. We're not dealing with this equation here. And looking at this equation, what do I know about the k and h? They are both what? 0, yes? So we can just go on and fill that in. What is y minus 0? Y, yes, because y minus 0 or y plus 0 is just going to be y. Yes? Do we agree with that? And what is happening to this y without that? Being squared, yes? Because what are we left with? Just y plus 0. Well, that's just gone, isn't it? Because adding 0 doesn't change anything. So we're really just left with y is equal to 1 over 4p. X is equal to 1 over 4p times y squared, yes? Look back at that other page that you have. Look at the first page, that graph. Isn't that one of the two equations? Y is equal to, or x is equal to 1 over 4p times y squared? Yeah, that is the equation. It's just the fact that the vertex is what? 0, 0. And this is part of the reason why I'm trying this out this year. I want to see if this works better. Because this whole equation, x equals 1 over 4p times y minus k squared plus k, is the equation. But it works out that this here is the equation when the vertex is 0, 0. So really, we're just plugging in 0, 0, and that's our equation. Now, what equation did they give us? negative, I want to say 2x, 4x equals y squared, yes? Because that's our equation. Now, what are they asking us to do with it? Okay, so we want to find the focus, directrix, and axis of symmetry. Well, we know that we're using the equation that has x equals, yes? X equals. Well, the focus is h plus p comma k, yes? The directrix is x is equal to h minus p, and the axis of symmetry is y is equal to k, yes? So the three things we need is the value of h, the value of k, and the value of p. Do we know what h is? It is? What's k? What's p? Do we know what p is? No. But where does it appear in the general equation? On all three, it's the 1 over 4p. Actually get a highlighter. Because it appears right here as the 1 over 4p, the 1 over 4p, the 1 over 4p, yes? Because that's where it shows up in the equation. Is as that 1 over 4p, yes? So if I can find in the equation they gave me, negative 4x equals y squared, where that shows up, what number is taking its place, I can find the value of p. Now, if we look at the equation, what do we have? X equals 1 over 4p times y squared. The x is by itself, yes? And luckily in this equation, do we have x by itself? No, but we need to get it by itself, yes? So what can I do to get it by itself? Divide both sides by negative 4. Because negative 4x divided by x is just going to be x. And over here we'll have y squared over negative 4. Does that look like this here? Well, no, y is up in the numerator, yes? What we can do is we can move it out to the side because we're saying negative 1/4 times y squared. Whenever I multiply a fraction by a whole number, it always multiplies with the numerator. So I can move it over to the side and say negative 1/4 y squared, because that's going to be the exact same as negative y over 4, or 1 over, or y squared over negative 4. These are the same. But I wrote it this way because now, does this equation look like our general equation? Because we have that fraction lining up. That's what we really want, is that fraction to line up. Because when we look at this here, I'm going to grab the highlighter again. X is by itself here, yes? Is x by itself here? Yes. Okay, you need to move. We have our y squared term here, and our y squared term here, yes? So this 1 over 4p, what is it matching up with? Negative 1/4. So where the p appears is in that 1 over 4p. The similar location in the equation we have is the negative 1/4, yes? So whatever the value of p is, it should be in there with that negative 1/4, yes? This negative 1/4 and this 1 over 4p are in the same place, yes? So if I want to find p, well, I can set 1 over 4p equal to negative 1/4. Because whatever p is, if we plug it in, it should give us that negative 1/4. Questions on this here? Now we just need to solve for the value of p. Our first main step is going to be multiplying both sides by 4p, because we need that 4p out at the bottom of the fraction. Well, here 1 over 4p times 4p. Well, the 4p and 4p would cancel. Leave me with 1 is equal to. Negative 1/4 times 4p would give us negative 4p over 4. Any questions on this here? Well, what's 4 divided by 4? 4 divided by 4 here would be 1. So really we have 1 is equal to negative. So what can we do here? Divide both sides by negative 1, telling us p is equal to negative 1. Any questions on any of this here? Any questions on any of this here so far? So we said the value of h was what? The value of k is, and the value of p is negative 1. Now our focus for this here is h plus p, comma, k. Well, what is h? Plus, comma, 0 plus negative 1 would be? So our focus would be negative 1, comma, 0. Now our directrix, they told us, is x is equal to h minus p. What is h? Minus. What is 0 minus negative 1? Negative and negative make a? So x equals axis of symmetry is y is equal to k, which is just 0. And that's it. Questions on this here? Any questions on any of this here so far? Any questions on anything we've done thus far? So looking at this here, we have negative 2x equals y squared. So we know the vertex is going to be what? Zero, 0. Now we need to figure out which of the two equations we're going to use. Are we going to use y equals 1 over 4p, parentheses x minus h squared plus k? Or our x is equal to 1 over 4p times y minus k squared plus h? We're going to use the x is equal to 1 over 4p times y minus k squared plus h. But we do know that h and k are both 0. So when matching this up, we can go on and just plug those in. Zero. Because again, we're plugging these in to really see what does the equation look like that we're going to be matching this up with. So since the vertex is 0, 0, we're really just sticking with this here. Now we know that the value of h is, the value of k is, and the value of p is. Do we know what it is? No. So we need to find that. That's what we're going to find. And we're going to use the equation to find it. Any questions on this here so far? So we need to get negative 2x equals y squared in the form x equals 1 over 4p y squared. We need the value of x by itself. So what can we do to both sides to get x by itself? Divide both sides by negative 2. Because the negative 2x divided by x is going to give us x. Which would be the same as x is equal to negative 1/2 y squared. So we have x by itself, yes? Just like in the general equation, x is by itself. On the other side, we have y squared and y squared. And our negative 1/2 is matching up where the 1 over 4p should be. So if I want to find the value of p, I'm going to set these two equal to each other. So we're going to set 1 over 4p equal to negative 1/2. Now what can we do from here? Multiply both sides by 4p, because again, we're trying to solve for the value of p, and since it's in the bottom of the fraction, we're going to need to multiply both sides to get it out of the bottom of the fraction. Now 4p times 1 over 4p, the 4p and 4p will cancel out, leaving us with just 1, is equal to negative 4p divided by 2. What is negative 4p divided by 2? Negative 2p. Now what can we do next? Divide both sides by negative 2. Negative 2 divided by negative 2 will simplify, leaving us with p is equal to negative 1/2. P is equal to negative 1/2. Axis of symmetry. Now, because we do have the equation x equals, our focus is h plus p comma k. Our directrix is x equals h minus p, and our axis of symmetry is y is equal to k. So focus is h plus p and k. Well, h and k are both, so we know that's going to be 0, plus, what is p? What is 0 plus negative 1/2? So the focus is going to be negative 1/2 comma 0. The direct 6, x is equal to, well, it is our k minus p, yes? Well, k is minus negative 1/2. Well, the negative and negative make a positive. So 0 plus 1/2 is, and the axis of symmetry is y is equal to k, which would be 0. And that's it. Questions on this here? What term is being squared? X squared. So we're really going to be looking at the y is equal to 1 over 4p times x minus h squared plus k, yes? Or really, since h and k are both 0, because we're really looking at since we know that h is 0, k is 0, because again, for these here, the vertex is at 0, 0. The values of h and k are both 0, yes? So really, for us here, for this problem, and for what we're doing in this part, h and k are both 0. So we're really just left with y is equal to 1 over 4p x squared, because h and k are both 0. They're both 0. Questions on this here? So really, for focus, direct 6, and axis symmetry, we need to know the value of h, the value of k, and the value of p. Do we know all three? Well, we know h is 0, k is p. We don't know. But I do know if I can get the equation, the given equation, into y equals 1, or y equals a number times x squared, because 1 over 4p is just a number, yes? Because p is just going to be some value, then I can find the value of p. So what do I need to do to our given equation? Or do I need to do anything? Is the y, because do I need to do anything to that equation? Well, we can make it into a fraction, but it is already set up, isn't it? Is y by itself. Yeah, and we have a number being multiplied in front of x squared. It is already set up. So really, we're just saying the 0.5 is taking the place of 1 over 4p. It doesn't matter if it's a fraction or a decimal. Either will work just fine. So we can just go on and set it up that 1 over 4p is equal to 0.5. Now what can we do to both sides? We can multiply both sides by 4p. Now what is 4p times 1 over 4p? So what would this be? Okay. How would we multiply those two together? Because it would go on top, wouldn't it? So it would be 4p times 1, which is 4p over 4p. What's the other side? What's 0.5 times 4? 0.5 times 4 is 2p. What is 4p divided by 4p? Because again, we multiplied by the denominator, but what the denominator is. So 4p times 1 over 4p will be 1. They will cancel out. We just canceled them out in all the other ones. We never wrote it out. Now what do we need to do next to get p by itself? Divide both sides by 2, which tells me p is equal to 1/2. So our focus for this one here is what? So we're dealing with y equals, yes? So this would be our h, comma, k plus p, because that's the one it matches up with. H is 0. K is 0. Plus, what is 0 plus 1/2? So the focus is going to be 0, comma, 1/2. Our directrix is our k minus p. So we'd have 0 minus, which would be, and the axis of symmetry is x is equal to h. What's the value of h? 0. And that is it. Questions on this here? Questions on anything we've done so far? All right, we're